What's up, guys? Today I'm going to be solving the USACO 2019 February Contest Bronze Division, Problem 2, the Great Revegetation. So, a lengthy drought has left Farmer John's end pastures devoid of grass, and he wants to revegetate. In his shed, he has 4 buckets, which each correlate to a different grass seed. He wants to sow each pasture with one of these seeds. However, each of his M cows have 2 favorite pastures, and he wants to make sure that he plants different types of grass in each of their favorite pastures, so that every cow can always have 2 types of grass to eat. And they give us that no pasture is a favorite of more than 3 cows. Okay, so this is a graph problem, and I've illustrated the sample input here for you guys. And so basically, each of these nodes is a pasture, and each edge is a cow, and the nodes it connects are its 2 favorite pastures. And every edge can't connect 2 nodes of the same color because we want a varied diet for the cows, right? So each color represents a different grass type. And this is the sample input they gave us. So 4 is connected to 3, which means that um, one of the cows, her 2 favorite pastures are pasture 3 and pasture 4. So the way we would approach this problem is, well, if you look at the sample size, n is between 2 and 100, and m is between 1 and 150. So we can easily just loop through all the possible solutions, or all the possible grass types for each node, and just take the one that works, right? So let's say we started off at 1 right here, right? Well, we would just give this grass type 1. By the way, the number in blue is the grass type. So we would give that grass type 1 because it's free, it's open, right? So let me copy down the sample input actually. Um, okay, so this is n, which is the number of pastures, and m, the number of cows, or the number of edges. Okay, so we can just loop through the inputs. So first, um, actually no, we wouldn't loop through the input. Okay, so we use this to build the graph we have right here. We can use like an adjacency list or whatever. Um, actually, you don't. We can just. Okay, yeah, we will have 2 lists. One being um, one of the pastures. Like let's say we can separate each cow's favorite pasture into two into based on the smaller one and the bigger one. And we'll have one row or one list be all the small favorites and another list be the big favorites. So that way we can easily keep track of if they're related or not based on the index of the list. Yeah. I'll get more into that later, but the way we would do this by hand is we'll start at 1, and then what seeds are open? We have 1, 2, 3, 4, right? Because we haven't used any yet, so we're just going to take 1, and we're going to put it here, and then we're going to go on to pasture number 2, let's say, if that's the next one in our list. Okay, 2 is connected to 1, so um, we can't use the same seed. So we'll use seed number 2, okay? And then what's the one that's connected to 2? Well, that's 5. So we can't use 2. Can we use 1? No, because pasture 5 is connected to pasture 1, and pasture 1 is already using seed type 1, so that means we have to use seed type 3, right? And the same thing for 4. 4 is connected to pasture 2 and pasture 1, which both have their respective C-types. But it's not connected to pasture 5, which means that we can use C-type 3. And the same thing, we go to pasture 3, it's only connected to pasture 4, which means we can use any C-type other than the one pasture 4 is using. So we're just going to take the smallest one available, which is 1. So that is basically our solution. And to give a more detailed answer, right, let's think of it more code-like, right? So we can loop through every pasture, right? We only need to do each pasture once. And then we need to check what C-type is available. So we can loop through all the C-types after looping through the pastures. So that's 2 for loops. And then, all right, for each C-type, how do we know if it's available? Well, then we can loop through each edge. Yeah, we can loop through each adjacent node to the current node we're looking at and see if that C-type is already being used. So what time complexity? That is O of, so each pasture, that's O of n, and then we loop through each C-type, that's what, 4? So, well, yeah, whatever. And then we loop through each cow or each edge, and that's m. So this is O of n times m, I assume. And with our input sample sizes of, what was it, like 100 and 250? 150, yeah. Okay, this will run in time with time to spare. So because of that, and because I like Python, I'm going to code this in Python. So first, let's get our input file. This one's called revegetate.in. Okay. And then I'm just going to do the import work right here. Okay, so we can read in the first line, and we'll map a int to them. And then for our data, I'm going to build 2 lists, so we'll call that A and B. Alright, and then we need a way to keep track of which grass types we're using. So I'm going to build a list of empty zeros called grasses. And the max number is 100. So I'll do 101. Okay, now we need to get our data. So range m. Okay, and then so for our sample data, right? So 4 and 1, we can just the list on the left will say has the small one. The list on the right has the big one, so it'll look something like this. Just to make things run smoother. Right, so 1's connected to 4, 2's connected to 4, yada yada. Okay, so we'll have a dot append. We'll take the minimum one in A, and then we'll take the large one in B. Okay, so that should be all our inputs done. And then now we can start our loop. So if you remember what our plan was, I didn't write it down, but we're gonna loop through each node first. So each node is a pasture, so we'll say for pasture. And there are n pastures, but they start at 1 and end with n. So we're gonna have to do something like that. And then for each pasture, we're gonna loop through our C types. And those go from 1 to 4. And if you're confused about the 5, that's because it ends at 5, ends before 5. So we need to see if it's available. So we're going to set it to available to start, right? And then we're going to somehow check if it's available. And if it's not available, okay, so we're going to, check. If it's not available, then we're going to move on to the next C type, right? But if it is available at the end of our check, of when we check it, then we can just break out of this because we know that that's the C type we want, right? So how do we check if it's available? Well, we can loop through all the neighboring nodes of the current node and see if they've already been assigned a C type. And if that C type is the same as the one we're currently on, then we're going to move on to the next C type, right? So we can do, we can say for each cow in range M, because right, we have M edges. If B of cow is equal to the current pasture, right? So that means A of cow must be the other pasture that's connected to the one we're currently on, right? Because A and B, they have the same index. The way we inputted it, that means they are connected, or they are the favorites of one cow. And the grasses, so grasses is a list, and the index means that that cow or that pasture is whatever C type we put in the grasses, right? So right now they're all zeros, but we're going to assign them later on. So if B of cow, right, is equal to pasture, so that means that if it's a favorite pasture that is also, how do I put, all right, so if B of pasture, right, so that means it's connected like this. So this is the one we're currently looking at in the loop, and we're looking at all the possible other nodes, all right? And if B of cow is equal to pasture, that means that they're basically connected, right? So if they're connected and grasses of A of cow, right? Because, hold on, wait. Okay, so, all right, sorry. So if we're looking at each edge actually, not each cow. So pretend like there are a bunch of edges, right? So if we're looking at edges until we find one that is connected to the current cow um, that has a favorite in pasture, right? So that is what the if B of cow is equal to pasture does. And then the grasses of A of cow. So this is A of cow, and the pasture, the grasses is a list, right? So we'll say grasses. And these are the indexes. Let's say 1, 2, 3, 4, right? So if grasses, they all start at 0. But if grasses of 2 is like 3, let's say, that means pasture number 2 is currently already using C type 3. So that means we can't use C type 3 for the current cow or for the current pasture because it's connected to another pasture that's using it already. Right? Hope that makes sense. So if that is true, right? That means we can't use this C type, so it's not available anymore. So available is going to be false, right? And then we're just going to move on. We're going to loop to the next C type. Okay, so if we go through all of that and we go through all of the connecting nodes and it's still available, then we're going to put it in our grasses list. So grasses for this current pasture, we're going to set that to whatever C type happens to be at the time. Okay, and then we can just print out the C type. So let's test this out on our sample case. So the output they gave us was 12133, and oh yeah, I forgot. Okay, so we're gonna have to make this into a string because they want it all on one line. So we're gonna have to make an answer variable, and then we're just gonna concatenate it with the C type. Alright, and at the very end, we'll just print out answer. Okay, so there we go. And we can try submitting it. That's not the right file. Alright, here we go. And hopefully this works. Come on. Yeah. Alright, I think we did it, guys. I know I went kind of fast on that one, but it's not that difficult, I would say. It's like, it's a pretty, um, you have to loop through every single one. I'll just run through what we did one last time. So we loop through each of the nodes, right? And when we start, none of them have been assigned C types. So I'll just draw this again. So we start at pasture 1, which was this one, right? And then we look at all the available C types. So we loop from 1, 2, 3, 4. So we start at C type 1. We look at the nodes that are connected to it. This one, and this one. Do any of these have a C type already? And if they do, is it C type 1? No, they don't. So we can assign C type 1 to here. I'll write the C type in green, because grass is green. Right? And then we're done. We break out of the loop, we assign it, or we don't break, but like we assign it, we move on to the next pasture, okay? So pasture 2 was over here. Okay, we loop through the C types once again. 1, 2, 3, 4. We're on C type 1. We'll look at each of its adjacent nodes. These three, right? Do any of these have a C type already? Yeah, pasture 1 already is assigned C type 1, so we can't use it, right? We break, we move on to the next C type. We're on C type 2. Do any of these have C type 2? No. So we assign this one C type 2. Alright, we move on to pasture number 3, which is all the way over here. We look at its neighbors, only this one, right? We're looking at each of these grass types first, and then we look at each of its neighbors. Oh look, this guy hasn't been assigned anything, so we can take C type 1 and put it here. Alright, on to the next pasture. Pasture number 4, right? So I hope you can see what we're doing here. We're just looping through each pasture, and for each pasture we're looking at all the possible seed types, and by looking at all of the adjacent nodes, we're eliminating seed types that have already been used. So yeah, I'm just going to finish this off. So we look at pasture 4, we use 1 over here, we use 1 over here, and we use 2 over here, so that means we have to use 3 here. And same thing for 5, you can loop through all of them and check. We're going to end up using 3. So if you go through our final answer going from 1 to 5, 1 is 1, 2, 3 is 1, 4 is 3, 5 is 3. And that is how we got our answer. So I hope that was able to clarify it a bit more. But yeah, graphs are fun if you take the time to practice them. And I think they're actually really quite interesting. So yeah, this was the Great Revegetation, and I hope you guys learned something. And I'll see you next time.